So it is 10:30 at night. My wife got sick again, so I can't be here tomorrow. I did manage to grade the tests y'all took last week, and they were pitiful. So I'm going to go over this test in this video tonight at 10:30 at night. You're going to figure out what you're doing wrong and, take notes and copy it down and turn it in to me Wednesday for a grade, and then you're going to take another test Wednesday. Because, man, I can't really do anything about your last 6 weeks grade until you take your challenge exam, though. So that grade is what it is. But there's still the six weeks. All right, number one, solve the equation 2 cosine squared minus 3 cosine plus 1. You might look at this as 2x squared minus 3x plus 1. Just do that so you can factor. I hope that makes sense. But if you do that, you should be able to factor it pretty easy. I believe that does it. So this tells me that x is a half or x is 1. Now, what I was doing here is I was letting x be cosine theta, if you hadn't caught on to why I did that. I did that because it's easier to factor an algebraic expression of x's versus cosines for most people. So I have that the cosine of theta is a half, or the cosine of theta is a 1. All right, so where is cosine of theta 1? I noticed a handful of kids had drawn a unit circle on the front of their test, and they only filled it out as they needed it. Cosine on the unit circle, cosine of any angle is x over the radius. If you're on the unit circle, the radius is 1. You can only have a cosine value of 1 there. So this tells me here that theta is pi. The other one is that the cosine of theta is a half. So I'm thinking about points on a unit circle. There's one right here. You're 1/2 root 3 over 2, and that is going to happen at pi over 3. And the other place that the x value would be a half would be down here. And I'm ridiculously tired, but your values here would be a half and a negative root 3 over 2. And that happens at 4 pi over 3. So, what have I got here? Not 4 pi, 5 pi. Sorry. Choice A. That's what she is. She's choice A. Now, one of the things that aggravates me the most is I showed you guys how to cheat. I did. And I don't want to spend a lot of time on this, but I showed you how to cheat. I don't want to spend a lot of time on it because I don't have a lot of time. It's 10:40 at night right now. I'd like to go home and go to bed. But here we are. And a couple of you won't even appreciate this. That's probably what aggravates most out of me. But I can plug in answer choices. And yeah, I got to do it by head. 2 times the cosine of a 0 squared minus 3 times the cosine of a 0 plus 1 should equal 0. Well, the cosine of 0 degrees is 1. This is 0 degrees, 0 pi, whatever. This is 2 times a 1 squared minus 3 times a 1 plus a 1. And by God, that is 0. You can plug in answer choices, kids. You start talking about pi over 3, you go here. That's pi over 3. The x value is a half. 2 times the cosine, 2 times a half squared minus 3 times a half plus a 1 should be 0. Well, that's going to be a quarter. You square a half, you get a quarter. Minus 3 halves plus a 1 should be 0. And it is because 2 times a quarter is a half. You have a half minus 3 halves plus 1, and by God, that is 0. You could have just plugged in answers. You could have. All right, moving on to the next one. 2 sine squared theta equals 3 cosine theta plus 1. Now I know, and this is given to you, it's one of the few Pythagorean identities that's given to you on your form sheet. I swear it is. I've got it here somewhere. I just printed it off. I can go make some copies. Where is she at? She's right there. I don't know what's up with the double T's they're using, but whatever. This has got to be a typo. I bet I opened up a PDF in Microsoft Word. Whatever, I'll fix that later. Anyways, I know that that's there. So what I want is I want to replace this sine squared with something. And it turns out that cosine squared is 1 minus sine squared. So 2, whoops, I did that backwards. I know that sine squared is 1 minus cosine squared of theta. So 2 times 1 minus cosine squared of theta is 3 cosines of theta plus 3 because I know how to distribute. And again, I know how to distribute. 2 minus 2 cosine squareds of theta is 3 cosines of theta plus 3. Shift everything right, actually, on this one. All of them go right. So 0 is 2 cosines squared of theta plus 3 cosines of theta. And then when the 2 moves over, 3 minus 2 is 1, so plus 1. And again, it might pay dividends to think of this in terms of x's as opposed to cosines, because then you have something that should factor. This is meant to be done without technology. It should factor. To create a 2x squared, it takes a 2x and an x. To create a 1, it takes a 1 and a 1. You got to add a 3, both positive. This will tell you that x is negative 1/2, and this will tell you that x is negative 1. And again, I was letting x be cosine of theta. So the cosine of theta is a negative 1/2, or the cosine of theta is negative 1. I use concepts of the unit circle. Here, the ordered pair is negative 1, 0. That's at pi. This is pi. The angle of interest is pi. That means I can't be choice A, I can't be choice C. Should have never been picked. Negative 1/2 is going to happen here and here. This would be at 2 pi over 3, and this would be at 4 pi over 3. So, choice D. Done. All right, there's 2 down. 10 to go. Sine of pi over 12, what you should probably do is convert that into degrees. Take pi over 12, you multiply it by 180 over pi, the pi's cancel, and if for some unknown reason you can't figure out what 180 over 12 is, you do have access to these little calculators, and they can do it. You can type in 180 divided by 12, and you get, whoops, try that again, 180 divided by 12 is 15. I know it's kind of hard to see. Anyways, you're actually finding the sine of 15 degrees. Now, when I see 15 degrees, I've got to come up with 2 things I'm comfortable with that'll get me there. And I feel like I can do the sine of 150 minus 135. And I'm sure there's 100 other ways to do it. But I'm going to view this as the sine of 150 minus 135 degrees. That's what I'm going to work with. And that answer document has flaws. Let me get another one. I know I had one floating around here somewhere that was in good shape. Now I did minus, all right? That's not something that exists on this sheet. These signs are going to change place. And they're using S's, so this will be S and this will be T. So whatever you want, A, B, nobody cares. But anyways, it's sine S cosine T minus cosine S sine T. Sine 150 cosine 135 minus cosine 150 sine 135. And then I just got to think about my unit circle. That's what I've got to do. If I'm at 150 degrees, I'm pretty confident that the y value is a half. If I'm at the cosine of 135 degrees, I'm pretty confident the x value is negative root 2 over 2. If I'm at the cosine of 150, I am very confident the x value is negative root 3 over 2. And if I'm talking about the sine of 135, I'm pretty confident that's root 2 over 2. And again, this was all from the unit circle. That's where those values came from. Let's see here. We're going to have a negative times a negative, so that's going to be positives. We're going to have some plussing here. This will become negative root 2 over 4 plus root 6 over 4. That doesn't look like anything like the answer choices, except it's not that one, not that one. What they actually have done here is, instead of what I did, they pulled a root 2 from both of them. But you can still pull a root 2. And should I pull a positive or negative? I don't think it really matters. If I pull a root 2 from a negative root 2, I have a negative 1. If I pull a root 2 from a root of 6, I have a root of 3. And it's all over 4. So that looks like choice A to me. Maybe backwards, but it's choice A. Let's see, 4 cosine of 5 pi over 8 cosine 2 pi over 9 minus sine 5 pi over 8 sine 2 pi over 9. And I just recommended you convert into a degree. I honestly think it'd make it easier, but it might not. You do you. I'm going to convert to a degree. There's lots of ways of converting to degrees. The easiest one is just remember that pi is worth 180. And 5 180 over 18 becomes 5 times 10, doesn't it? Because 1800 is 180 10 times. That's 50 degrees. 2 pi over 9. 2 times 180 over 9. 180 divided by 9 is 20, so this becomes 40 degrees. So this is cosine 50, cosine 40, minus sine 50, sine 40. So what do I have here? I have cosine, cosine, minus sine, sine. Cosine, cosine, minus sine, sine. And she's right there. Cosine, cosine, minus sine, sine. That's the cosine of s plus t. That's what she is. So this is equal to the cosine of 50 plus 40, which is the cosine of 90. And if we unit circle that idea, 90 degrees is right there. The ordered pair is 0, 1, and that is my cosine value. Choice C. Not a hard problem. Let's see, 5 looks like the right-hand side of some form. That's what she looks like. Actually, I take that back. She looks like this if you were to reciprocate. If you were to reciprocate, it wouldn't be tangent, it'd be cotangent. This is the cotangent of a plus formula, 80 plus 70. And if you take 80 and 70 together, I guess you get 150 degrees. So the cotangent of 150. All right, I'm thinking about 150 degrees on the unit circle. It'd be about right here. The ordered pair is negative root 3 over 2, 1/2. And I made you guys memorize this stuff. You memorize all this stuff. Sine is y, cosine is x, tangent is y over x, and cotangent of any angle is going to be x over y. So this is going to be negative root 3 over 2, and it's going to be divided by 1/2. Now, I don't know how you think about things. If you've never understood when I've canceled out these things right here, go to 5th grade. In 5th grade, they would have said to divide by a fraction, you multiply by the reciprocal. Then maybe you see the cancellation. Choice B. What really sucks is after I get done with your video here, I've got to do one for Algebra 2, then I've got to type instructions for a substitute, then I've got to make copies. I ain't leaving the school till 12:30. That's what sucks. You're welcome, by the way. We are tasked with finding the cosine of alpha plus beta, which is that little guy right there. Cosine A, cosine B, minus sine A, sine B.